there should be a way to let all the people get in.
Yeah, the room seems to be filling.
Yes.
Okay.
Yes, and just for information, everyone outside will be muted, and when we have question and answer sessions, they will be unmuted. Except presenters, of course. Presenters will not be muted.
That's perfect. So do you want to put my slides, Georgi, or should I share them myself?
It's up to you. I have them here, so the way you prefer.
Well, I share them because then I need not always ask you, and if it doesn't work, then we do the other way.
Yes. Okay. May I ask our assistants just to make Max a presenter if he is not a presenter yet? I think you are included as a presenter.
Yes, you're already a presenter.
Okay, good. Very good.
Thank you very much.
I believe you all see this title slide that I shared now. And it's already 1 minute past, so I think it's time to start. So welcome everyone to today's information session prepared by the Chips Joint Undertaking concerning our call 2025. This call has already been announced, first time being at the brokerage event of the industrial associations of the ECS, or Electronic Components and Systems Industrial Associations of the Chips JU. But the aim of today's session is actually to focus on the topics on automotive electronic components and systems, which are part of that more general call. So these topics in particular are on RISC-V automotive hardware platform. This is a focus topic from the Horizon program of Chips Joint Undertaking, and it concerns call for proposals for innovation actions. Then we have the topic on AI-assisted methods and tools for software-defined vehicle engineering automation. Again, a focus topic from that IA call. And we have a separate call on heterogeneous integration for high-performance automotive computing, which will be, again, an innovation action, a call for innovation action proposals. So this information section will provide you with some more insights into these three topics, all of them related to automotive developments. And without losing much time, I'll just introduce you to the agenda, and then we'll jump directly to our presentations. The first one will be made by our colleagues from the Commission, Max Lemke. It will be an overview of the European Automotive Action Plan. So he will put these topics that we are going to talk about later on into the more general context of the recent, I would say, non-trivial geopolitical situation, not only in Europe, but worldwide. Then I will continue with focus topic 1, which will be RISC-V automotive hardware platform. This will be a slot of 20 minutes. I believe that we will have something like 5 minutes after each slot on the focus topic for specific question and answers. But in the end of the day, we will also have a dedicated general session for question and answers. Then the second focus topic will on AI-assisted methods and tools for software-defined vehicle engineering automation will be presented by my colleague Oscar Espinosa. And the call topic on heterogeneous integration for high-performance automotive computing will be presented by my colleague from Chips Joint Undertaking, Eric Fribourg-Blanc. So now I think, just I need to inform you that this session is recorded. So if anyone would mind being part of a recorded session, it's now the time to react accordingly. And that brings me to the first presentation, which will be made by Max Lemke. Max, you're muted. Still muted.
So can you hear me now?
Yes, we do.
Yes, sorry for that. So yeah, welcome to all of you in this information session on the automotive activities now under this work program of the Chips JU. I'm Max Lemke. Most of you know me. I'm coordinating the automotive action plan and the activities on automotive in DG Connect. So I will give you a bit the policy and the overview of what we are doing before we then dig into the details of the calls. You have seen a lot of communications by the Commission recently. So the competitiveness compass, you hear the word competitiveness, you also see a lot the word strategic autonomy. We have had the one on clean industrial deal, basically saying, yes, clean, but it has to be in sync with industry and with staying competitive. Automotive action plan, I get into that. And you have a lot of defense and security related issues as well that are addressed by the Commission. That's a bit outside here, though I would say some of things that we discuss here are broadly applicable. Now, on the automotive action plan, we have taken here for the automotive industry a strategic approach. And that also boils down to what happens in the Chips JU. It's different from what we do normally. Or very often, it's not water can principle, so everybody puts the best research up. It's also not bottom up, but it's focus areas where European collaboration will make the difference for European industry to stay competitive. So we link the research and innovation, and mostly innovation actions, to what is important for European industry. This whole thing was done very quickly. We had originally foreseen to communicate on the automotive action plan end of the year, but then because of the situation in the industry, and you have read the press, we pulled it forward into the first 100 days. And there were in these first 100 days, there were 6, or I would say one was split in 2, and there were 7 dialogues on level of Commission President and Commissioner or Vice Presidents. We were responsible for one of them, was Vice President Virkkunen on innovation and digitalization. And that basically what was discussed there and what we knew from you and also in other discussions with the constituency became the plan. And there was obviously also other topics addressed. That was decarbonization, competitiveness, resilience, skills, and also the value chain, the level playing field, and the business environment. You may know that at this event with Vice President Virkkunen, industry, through their associations, presented their declaration to collaborate on an EU software-defined vehicle. So that was just a statement, yes, we are with you, and we are also working on this. So when I look at the chapter on innovation and digitalization in the action plan, and that's what I want to focus on now, there is one topic which is called digital vehicle. We look at a European connected and autonomous vehicle alliance, and I would say that is what we call the digital vehicle. It goes beyond connected and autonomous, but connected autonomous is one of the key issues there, but there are others as well. And obviously, a lot of these things are broadly applicable in the vehicle. So common architecture elements across hardware, software, the vehicle. And cybersecurity obviously is a clear point in there. What I will not focus on today, but just tell you, there's also some reflections on data, for example, on how you can train AI models, sector-specific AI models. I would say you can call them large language models in the sector, or you can also call them, if you want, small language models, whatever you prefer. There is a part on batteries, and there's also a look at the regulatory framework, so at cross-border test beds or regulatory sandboxes where the standard regulation does not apply in order to test autonomous driving, and an idea to harmonize the market on autonomous driving across the member states. So when I look at budget, I would say on digital vehicle, we plan to spend around 1 billion together with industry and member states. And we could also say we spent 1 billion just commission money on automotive in general, but that includes as well charging infrastructures and batteries. So 1 billion that we have available. We are also thinking about a future getting some of the automotive activities together, which are purely automotive, not all of them, not all in one part. We also think about, there's also thought about an IPCEI by member states on clean, connected, autonomous vehicles, but it's not yet clear what the target will be there. It's under discussion at the moment between the ministries, and it will soon go into industry. So that gives you a bit the overview of where we are. Now, if I boil it down to what is important for you, that's the European Connected and Automated Vehicle Alliance. And this one has 5 pillars. The part that you are used to in the Chips JU are the first 2. It's on hardware, in vehicle computing, and software-defined vehicle. And I tell you more in just a second. You have been involved in what is running there already. So we go into much more details. And it's on the future-proof, adaptable, flexible, and energy-efficient computing platform, integrating also the processors that can deal with AI in real time, in the inference phase in the car. We look at the software-defined vehicle platform, which is basically the glue between all the digital components in the car, so in the vehicle, the interface. I would say this applies as well a bit beyond the car to commercial vehicles, would even say to agricultural vehicles, and we could go beyond with these concepts. Innovative AI solutions. AI is the new game changer. Sector-specific Gen AI models is Europe's opportunity, and agent systems that go across these different models, these different sector-specific models that are coming up, in particular for autonomous driving, but also for operation of connected vehicles, for battery management, or when it comes to manufacturing and maintenance, predictive maintenance. Autonomous driving, we look for the transition via automated driving to autonomous driving and have to see what components are needed there, hardware and software. So what we address on SDV and hardware is very much applicable there, but we would also look in detail at what happens, what is to be done purely for autonomous driving. And last but not least, it's important to have large-scale testing. We are at the moment thinking on how we can test all these building blocks that come out of the research and innovation to have it contribute to the joint strategy. So that is the overview of where we are and what is supported. Now, if I map that into the usual architecture picture, every company has a picture like that, then I would say we start at the bottom level, that's the hardware platform. Then we have the software-defined vehicle level, which is the abstraction from the hardware, but also the interfaces, the APIs, and the middleware. And then we have the applications across the different domains in the car that draw, in some cases, on in-vehicle systems, but that may also draw on the cloud, on telco edge cloud infrastructure, telco edge cloud corridors. So that depends really on the application or on the combination of applications. And last but not least, most important for many companies is the development and engineering framework, toolboxes and tool integration. And that's what we are focusing on now under the software part in the Chips JU. And below at the bottom is what we focus in this call on the hardware part. So on the hardware side, what we are doing, and this is the pipeline of projects that you see here, already before under the Excel Joint Undertaking, we have Tristan and I think it was still the Excel, Tristan and Isolde to start with. Then we have gone towards a project that is on RISC-V for automotive, for the RISC-V automotive architecture, RISC-V open source, which is currently under preparation. I am a bit going beyond what I should maybe do, but I mentioned the acronym. So there is a proposal in preparation which is called Rigoletto, and we plan to have another one, and that's the subject of this call, on RISC-V, and we have one on chiplets for automotive. So a modular design of the chiplets in automotive. So basically we touch three areas here in hardware. We touch the advanced AI accelerators, we touch RISC-V automotive hardware, and we touch chiplets. Yeah, so that's the concept. And I tell you a little bit more, just but not much more though. Now, on the software side, we have basically, you saw the picture, the architecture picture. So we have one project running on hardware abstraction. That's called HAL for SDV, Hardware Abstraction Layer for SDV, that ensures efficient integration of the hardware platforms while maintaining compatibility. And it's also modular to allow exchanging. I think that's very important when you look at the current geopolitical situation. In geopolitics, you see we have export-import restrictions. And because of that, a European OEM may not sell the same car to China than to the US. When it sells to the US, it cannot have Chinese software. And when they sell to China, it cannot have US hardware because the US has export restrictions. And on the other one, the US has import restrictions. So it's very difficult, and the market becomes extremely difficult, and it's important that we can exchange components relatively easy. Now, shift to SDV, another activity that's just starting now, that's looking up, that's on middleware and APIs, and that is the kind of service-oriented framework that bridges between the hardware and the application layers. And now what we call for now is the third one in the row, which we find is extremely important because software or system engineering in general is extremely unproductive in the automotive sector. We have the customization of interfaces, we have the version control, we have test cases, we have validation, we have official certification. And a lot of the power of software engineers that we have is going into these, what I would call, unproductive tasks. And that at the same time where we have a skills gap. So that kills a lot of actors in this sector. So we have an initiative here, and where we also expect actors from outside the automotive sector to get in and help here. So we have the tool providers for automotive, but we also have engineering tool providers, very large ones, but also small ones who we think are extremely important to get engaged here. So we on purpose encourage to go outside automotive here, and we would also see what we pilot here in automotive to be visible and to be used elsewhere in other sectors. Are you still hearing me? Can somebody confirm that?
Yes.
Okay, thank you very much, because I don't see anything.
You're running a bit out of time.
I'm close to the end.
Yeah. Yes, I know.
So let me just show you this project pipeline where you basically see what we have. The yellow part is the part in this call. This again shows the strategic orientation of this. You can have the slides afterwards, so you will see it. And just as a final slide, I would encourage you to engage in this European ecosystem approach. Keep in mind Europe's strategic autonomy. So driven by industry who driven by European industry, European actors operating on a global market. Not the water can principle, but strategy where collaboration is needed for European industry, because they cannot do, the industry or the member state cannot do it alone. That means for me, it includes OEMs, tier ones, I say here, the automotive supplier, but then as well the integrated device manufacturers and tool providers, in particular in the two calls here. They play a crucial role, the IDMs and the tool providers here, but they should adhere in a way to what the industry needs. So I think that's an important point. Then it's horizontal and vertical collaboration. It means working across different OEMs, working across different tiers, because these tools are generic. They are non-differentiating. They help everybody. And we have, for example, some of the coordination actions in place to help also orchestrate that, like Federate, for example. Important point, I think you may want to recall a metaphor. If I think of platforms, you could see the automotive industry is somewhat experiencing a Wintel moment, as a colleague explained to me how he is memorizing it. So we are going towards a mass production of processor. That's in the Intel part in Wintel. And we go towards operating system middleware a la Windows, going across. That's the Windows part in this Wintel moment. And then differentiating on the application level. So the customer of the automotive manufacturers don't see anything on that level, but they see the application, and that's where the differentiation and where the different OEMs play with different customers and sell and compete. So one important ingredient there is open source as a key vehicle for collaboration. I would say that's true for hardware, RISC-V, but also for software, what we do on SDV. And it has some advantages. It abides to competition rules. So it's okay in the sense of competition. It's so far largely exempt from geopolitical restrictions as we understand it now. I say on purpose so far because at the moment, with, for example, the announcements from the US yesterday night, you never know what happens. But they would need some organization that incubates, that validates, that helps maintaining, that takes an architecture view. And I can tell you, we are at the moment in the preparation for the implementation of the Automotive Action Plan. We are looking in detail into that. So with this overview of the political situation and how we position the Chips JU and what we do here in that, I would like to pass on with 5 minutes delay to my colleagues. Thank you very much.
Thank you, Max, for that really nice, useful introduction to the global picture and to the dynamic geopolitical situation that we are evidencing these days. Now I'll take it up from here and we will go with the next presentation. So I forgot to introduce myself to those who have not met me before. My name is Georgi Kuzmanov. I'm with Chips Joint Undertaking. And next to moderating this session, I will be also making the presentation on the RISC-V automotive hardware platform, which is the first focus topic within the call 2025, currently open. So, Max already made a very nice generalization of our prior efforts into the field of the vehicle of the future, as we refer to. I would just like to again emphasize that the vision of Chips JU is to perceive the vehicle of the future as a holistic technology stack. That was also presented by Max, and as you have already evidenced, Chips Joint Undertaking, together with the Commission, has been preparing for this moment with activities that spawn as early as 2021. Actually, the first RISC-V projects were launched within dedicated RISC-V projects were launched in call 2021. So here on this slide, you can see an abstraction of the holistic technology stack of the vehicle of the future. So we have in the middle the hardware abstraction layer. On top, we have the applications, services, drivers, middleware, RTOs, just to enumerate some of them, some of the layers above, and the underlying hardware layer is on microprocessor, microcontrollers, hardware accelerators, sensors, interconnect systems on chips, etc. So what we have done so far, we have launched, and it's currently running, the coordination and support action, which is implemented by Project Federate. It was called 2023. On the software-defined vehicle platform, we have already the shift to we have the shift to SDV project, which is under negotiations. So it has been invited to negotiations. On the hardware abstraction layer, we have already running running project call for SDV, which has been awarded after the call 2023 of Chips Joint Undertaking. And on the hardware side, we have now Rigoletto under negotiations. Max also mentioned the preceding projects, which are Tristan and Isolde, coming from call 2021 and 22 respectively. They are not illustrated here just because they were more generic. So the first really focused automotive hardware project that we are running, and it's on RISC-V, is Rigoletto, which is currently under negotiations. What you can see here is actually what is missing. We still need to do some efforts on the automotive hardware platform, as well as some efforts on system integration and tools. And this is actually the subject of today's session, and it is also the focus of the topics that we are going to discuss today. So on the automotive hardware platform side, we have the RISC-V automotive hardware platform call. It's a focus topic, and a separate heterogeneous integration for high-performance automotive computing call. On the part of and it is on the part of the automotive system integration, we have the AI-assisted methods and tools for software-defined vehicle engineering automation. So today we will have 3 presentations on these 3 topics. So my role is here to go through the RISC-V automotive hardware platform topic. So what are the objectives of this topic? It is to translate the results of previous RISC-V calls into real hardware. And by real hardware, we refer to tape-outs of RISC-V based on processors and accelerators, and also their integration with other peripheral components and memories, and going down to heterogeneous integration process flows. I want to, and I must make the note here that the heterogeneous integration itself is not a primary objective of this call, as this will be covered by the call that my colleague Eric will present 2 presentations later. So the heterogeneous integration itself will be reflected there. So what is important also is that the culmination of this project that is expected to be funded as a result of this call includes industry-grade silicon tape-out. So tape-outs are really important as an output here. It should also incorporate a competitive RISC-V application processor to become a viable alternative on the market and for the European industry, alongside also with memories and accelerators and any other relevant IPs that will go together into one technological ecosystem with around RISC-V. It also, the result should take advantage of advanced packaging techniques, again, to be supported by a dedicated separate call within this year campaign of Chips Joint Undertaking. And all this shall be also accompanied by mature tool set to support the design process. Here, excuse me for this quite populated slide, but it is actually contains the expected outcomes as stipulated into the call text. So the expected outcome is a development of a high-performance automotive RISC-V reference hardware platform. So we are talking about an entire platform, an entire system that will have all its components enumerated here, and I will go only through the bullet points. This platform should include, at first place, high-performance RISC-V automotive application processors. Then it is also essential that automotive accelerators benefiting of artificial intelligence and machine learning are also considered. The system integration and interfacing is an important activity that should be performed in order to have a viable reference hardware platform. Software tools and libraries inevitably also go together with all the activities so that we have the correct support for the designers of the using such a platform. It is encouraged to have a collaboration with the software-defined vehicle initiatives, which Max mentioned in his presentation as well, so that we keep consistent and we keep together with the activities at the software side of the vehicle of the future technology stack. And last but not least, the proposal should also consider benchmarking and quality assurance activities. So, of course, you will get this presentation later on. You will have the opportunity also to go through the bit more detailed text, as well as you are invited, of course, to read the call text as applicants. Then a few words about the scope. It is the scope of this call is to address Europe's technological sovereignty in automotive processors and accelerators. In particular, 2 points need a special attention. This is first, high-performance RISC-V automotive application processors. At the second place, artificial intelligence and machine learning automotive accelerators. I must state here that this is a purely pre-competitive action, but again, it should have a clear perspective towards eventual commercialization by the European industry. It also should provide tangible silicon demonstrators. So we are talking not about proof of concepts, not about emulators. We are seeking for silicon demonstrators that can be deployed in an operational environment as qualified devices. So it is important to be as close as possible to market the deliveries of this action. Applicants are invited to clearly target the requirements of the European automotive industry. So it should be really very, very industry relevant activity. And where appropriate, you are also invited to consider the potential application of all these elements in other industry verticals. The aim of the call, after all, is to develop a common European platform for automotive processors and accelerators. To continue with the scope, a successful proposal should include tape-out. Again, I would like to emphasize that tape-outs are a mandatory outcome of this activity, using leading-edge technologies and multiple tape-outs actually on those leading-edge technologies. You also are supposed to propose an implementation roadmap with clear timeline and clear and ambitious milestones. By the end of the project, the applicants should convincingly indicate that they will reach global state of the art at that time, and also an evidence that eventually their proposal will be adopted by automotive OEMs targeting real industrialization. Proposals should define clear KPIs that are benchmarked against non-EU competitors. So it is important throughout the project that a close eye is kept on the competition overseas. Proposals should liaise with the projects selected in the two other focus topics, which my colleagues will come up with a bit later. And in particular, the selected proposal within this RISC-V topic must align with its activities, roadmaps, milestones, etc., with the selected proposal for the call on heterogeneous integration. So that is to say, again, to repeat, heterogeneous integration is not the primary objective of this call, but it is important that there are provisions and references and convincing mechanisms to exchange knowledge and to exchange also skills with the other activity on which will be dedicated on heterogeneous integration. Also, we are seeking after collaboration with relevant Chips GU projects, as we already mentioned, the RISC-V ones on Rigoletto, Tristo, and Isolde, but also collaboration with ongoing actions on RISC-V with the Euro HPC framework partnership agreement, which also, as we identified, there are a lot of commonalities in that activities. You also are expected to consider synergies with the Chips for Europe initiative, in particular with pilot lines as far as processes and technologies are concerned, as well as the design platform as far as tools, design tools and methods are concerned. A few words about the budget. Indicative EU budget for this call is 80 million. And we are expecting commensurate co-funding by the national funding authorities. The type of action is an innovation action that presumes high TRL. And again, I would like to emphasize that we are seeking for the highest possible TRL here, yet recognizing the high risk in this undertaking, in these actions, the funding rates will be like the RIA, the funding rates for research and innovation actions. This will be shown on the next slide. There are some specific eligibility conditions. There is a size limit for the participants, up to 35 partners may participate, and please note this is an eligibility criteria, so this number cannot be exceeded. At the same time, we, as a program, have always supported the inclusion of SMEs, and it is also a recommended number of participants to be 1/3 to be SMEs. There are certain restrictions for the protection of the European Communication Network, and this is stipulated in Article 22.5 of the Horizon Europe regulation. That in particular means that participation is limited to legal entities established in EU member states, Norway, Iceland, associated countries, OECD, and Mercosur countries. In order to guarantee the protection of the strategic interests of the Union and its member states, there will be, all the entities will be checked for their ownership, whether they are owned by, indeed, owned by entities which are established in the European Union, or and are they controlled by, if they are not controlled by non-eligible countries, or non-eligible country entities that may not, these participants may not participate in the call. A few words about the formalities for the application. There will be a page limit for the 2 stages. There's something I forgot to mention. The call will be in 2 stages. There will be a PO stage, that's project outline stage, and a full proposal stage. For the project outline stage, there are 60 pages limit for each of the 3 sections: excellence, impact, and implementation. For the full proposal stage, there will be 60 pages for excellence and 100 pages for the impact and for the implementation. Note that proposals with more pages are still admissible, but they will be evaluated up to the page limit. So anything in excess, written in excess, that on top of the page limits will not be taken into account by the evaluators. Here you can also see the EU funding rates, which correspond to the research and innovation actions funding rate. So 25% for SMEs, for non-SMEs, and 35% for SMEs and for universities or other non-for-profit organizations. And let me conclude with the timeline of the call. So this timeline actually holds for all 3 topics that we are covering today. So my colleagues will not have to repeat it. So the call has already opened on the 4th of March, all 3 calls, and they will close on the 29th of April. So they are currently open. You still have till the end of the month to submit your proposals. And then we will have an evaluation, which will take place in the beginning of June, between 2nd and 13th of June. Then there will be a funding decision for the call on the heterogeneous integration, which will be a 1-phase call. And there will be also an invitation to submit a full proposal for the focus topics on RISC-V and on AI engineering tools. So then you will have until 17th of September the successful proposals at the PO phase, project outline phase. Will have until 17th of September to submit their full proposals. The evaluation will take place in the second half of October, with funding decision expected on the 5th of November. And then the grant agreement preparation will start for successful proposals. So this is the general timeline. And these are some regarding the call for heterogeneous integration. The grant preparation will start in the course of July, as it will be a single stage call. So basically around November, the project monitoring on that particular topic may be initiated. So yeah, this is it about the timing about this topic. I suggest, unless there are really some burning questions, to go through all the presentations and then just in view for timing, and then to have our discussions with questions and answers. So, Bhaskar, I believe you're next.
Right.
Can you share your presentation?
I will share my screen. Can you see my screen now?
Yes, we do.
Okay, good afternoon. I'm Huáscar Espinosa, also program officer. Thank you to Max and Georgie for the context and also for providing some general information for the calls. As you likely know, this focus topic was already prepared last year, but it was delayed for this year. But this time we focus on automotive domain and particularly software-defined vehicles. Okay, so I will provide a bit of context first. As you know, the automotive industry is facing numerous challenges. Some of them are not new to this because, for instance, this growing design development complexity it was already there. The trend toward ever-growing digitalization and connectivity in a knowledge-intensive society leads to really this widening gap between development complexity and productivity. If you look at this graph, you will see that development complexity is on track to nearly triple over the next 10 years. So it means that automotive OEMs and suppliers will have difficulty dealing with this complexity because the productivity is not increasing at the rate needed to sustain innovation. As you can see here, for instance, for the tech leaders, which have a better performance, it's still hard. And then for automotive players, it's still harder. So all of this is, of course, challenged by massive talent shortage. As Max explained, education, professional training struggle to keep up with the tech evolution, mainly due to the complexity of digitalization, and this will impact the company's competitiveness. So as you can see here in this graph, about an average of 63% of engineering and R&D focused companies report these talent gaps in different areas of the engineering disciplines. So this growing crunch of engineering workforce will cause that Europe cannot merely allocate resources at the problem. Instead, we really need to streamline the software development process to handle this complexity. So while engineering automation frameworks have been already deployed to hundreds of software tools by already large teams of engineers, there are still a number of barriers for this massive adoption in the electronic component system industry, and particularly the automotive industry. And we know in particular for the high assurance market, where safety and security requirements are at the core. So the emergence of AI opens new possibilities here. So if we talk about AI, and particularly generative AI, Gen AI, is a powerful tool that can help accelerate software development and improve developer productivity. And as you can see here in this McKinsey study, generative AI tools can help developers complete tasks up to 2 times faster than traditional methods. In the first bar, you can see that documenting code functionality for maintainability can be completed in half the time, so 45 to 50%. Writing new code in nearly half the time, optimizing what is called here refactoring in nearly 2/3 of the time. With the right upskilling enterprise enabler, these speed gains can be translated into increase in productivity. Okay, yet there are still challenges, right? Succeeding with generative AI requires more than just technology. It necessitates right operating and usability models. So the value of generative AI will not be realized by merely adding new tools or generative AI tools, but it really hangs on organizations' ability to adapt to new ways of working and embrace transformative, seamless collaboration between the humans and also the tools, right? And this includes cultural challenges. So, for example, if an organization is underperforming software development, generative AI alone is unlikely to resolve the issue. So this is an important challenge. In addition, applying generative AI to critical embedded software is often more challenging than traditional software development. To embed generative AI, for example, organizations have to maintain a highly optimized code that could work within the computational resource constraints. They should assure, for instance, latency requirements, interact with all the hardware interfaces and meet all the requirements from hardware. So in safety critical applications in particular, such as automotive ones, software must undergo this extensive, for instance, validation, verification, testing to meet those of safety standards. So ensuring that generative AI meets the stringent certification processes, checked and improved by multiple reviewers, and use specific models or approaches to this additional effort for certification, for instance. Finally, while generative AI or AI in general can support software transformation, it is not a perfect solution. Most of the current industry level AI tools are problem domain specific or proprietary. So we can see, for instance, in the EDA domain, there are really mature tools, but they are specific and proprietary. So this limits the return of investment of the companies, and particularly SMEs. So particular SME, the automotive domain, which have a heterogeneous value chain, right? So developing proprietary solution will not lead to innovation without an adequate open integrated solution. That the applicability of these solutions will not work, as Max explaining on the concept of platforms. So let's summarize a bit the vision behind this focus topic. So the idea is to massively accelerate electronic components systems engineering efficiency to software engineering automation based on expanded use of AI tools. But the idea is to build upon a cohesive integration and collaboration between the humans, which have the ability to innovate and create intuitive solutions, and AI tools with the ability to propose solutions exploring huge search spaces and recognizing statistical patterns from large data. So the main goal is to develop these methods and tools aimed to provide productivity efficiency and SDV special and core case here, including design, validation, verification, and certification. And the scope here is all those methods that can automate the full technology stack. And as mentioned before, we should base these solutions in open platforms. Here, focus on SDV. And also, this platform should should support the characteristics of the SDV system, which are have stringent safety and security standards, and they need to meet and comply with legislation. One core aspect of this call is standardization and collaborative ecosystem based on open platform, as Max explained. This platform should also include reference architectures and process, which really are essential to allow multiple different companies to work together seamlessly, facilitating the integration of systems and components from multiple vendors, as is the case of the automotive domain. So there is, even if the focus is automotive domain, as you could see in the call, it's also accepted that best practice small proof of concept studies can be also defined for other sectors, like especially the healthcare domain, and also other digital industry domains. Okay, so this is an innovation action. The target TRL at the end of the project is 6 and 7, and the indicative EU funding is 20 million euros, which results in about 60 million euros for total costs. Okay, so as explained by Georgie, also this call needs to be linked and with other projects from other calls. And this will be done practically by connecting the collaboration with all the other tools. Okay, so I will summarize the expected outcomes quickly, but you have all this information detail in the call, right? There are like 3 main expected outcomes. The first one is the tools and methods themselves. So the idea is to standardize models, to connect them, these AI-based models with other tools, to work with legacy tools, and to have really building blocks that can be used in different scenarios. The second expected outcome is the platform itself. So it should be open, integrated, and extensible platform. So it means that there should be some general services that support specific life cycle activities in the SDV domain. And then we need to showcase these technologies, right? So concerning the first one, the specific methods and tools. So the idea is to alleviate engineering work and routine activities, to support them in complex tasks, facilitating and ensuring the consolidation and growth of their expertise. Okay, and this should also support the multidisciplinary, multi-stakeholder teamwork. So one core requirement for this call is the adoption of generative AI. So in different areas, from software models, architectures, for instance, the use of model-driven development and design tools is highly expected for this call. The code snippet generation, so it means code generators, automated refactoring of code optimization, or any assistant for code completion. So all of this could be based on AI tools, test and debugging tools, and even documentation. And as mentioned before, this should be providing support to the whole software lifecycle, and likely based on DevOps. So finally, there should be also 2 main aspects supported of engineering process. First of all, design development activities. So all about, here you can see some examples, some optimization tools. And we should also integrate hardware, because when we are designing software, we need to find what is the optimal solution based on the hardware, and other kind of features that are needed, for instance, to handle AI within these kind of systems. Finally, when we talk about validation and verification, we talk about space design exploration, for instance, for multi-criteria optimization, generation of tests, data sets, etc. And the second, sorry, I'm going too fast. The second aspect, which is about the platform, so we should think in having a well-defined engineering process around this platform for integrated also legacy tools, as you can see in this picture, other engineering tools in the life cycle. And it should be flexible, multi-stakeholder. Should be
Oscar,
open and...
May I ask you to speed up a bit? Sorry.
Yeah, this 2 slide more. And then platform and ecosystems should be also part of this. We expect as well taxonomies to be proposed for standardization. Finally, about showcasing the tools, what is at the core is the usability. So not only technical aspects, but also like comfort, stress, all that kind of things. And there should be a really strong human-centric seamless interaction with the humans, okay? So the call conditions, as the previous topic, this 2-stage innovation action, the size is limited to 40 participants. It should include significant representative numbers of actors across the automotive value chain. SMEs are the core, as in the previous topic, and there should be also tasks allocated to this link with other projects. And as in the previous call, there is some restriction for the type of calls. The funding is similar to the previous call. Okay, so that's all for this focus topic. Thank you. Apologies for the delay.
Thank you, Oscar. May I ask Eric now to share his presentation, so we continue with the last It is a call, not a focus topic like the previous two presentations. It's a separate call. And now, Eric, yes, we can see your slide. Please go ahead.
Okay, very good. Sorry, I want to so that I can do it. Okay, now it's coming. So I'm Eric Beaublanc, also from the Chips Joint Undertaking Program Officer, and I will present the call on the heterogeneous integration for high performance automotive computing. As already said, it's a one-stage call compared to the two previous focus topics presented. The conditions are repeated in the last slide, but they are exactly the same apart from the fact that it is a one-stage call. Trying to write the navigation here is not so good. So just a few slides of kind of, well, it's context, but it's a repeat from what is obviously known. So there is a fast transformation of the electronic and electrical architecture for automotive, which basically is to answer the demands on computation in the car, coming from a higher demand on autonomy in cars, advanced infotainment, much more enhanced connectivity, and electrification. That results into a shift from domain, let's say, design towards zonal architecture, and that actually has a strong impact on how to design system on chips or the modules. So the monolithic system on chips are untenable because you need diversity to address the zonal architecture, and unfortunately, if you design at leading edge with diverse technologies, things become complicated. So the idea from an SoC is to disaggregate it. So this is somehow a move which is going back to the past in a sense, but obviously for a very good reason. So it's we can speak about system in package, but not in the style that's where let's say from the end of the 90s, but closer to disaggregated SoC as in a modern way, which calls for a chiplet. So the chiplet will actually give flexibility to the design and reduce costs, shorten time to market, and bring, let's say, the necessary cost effectiveness cost effectiveness and fast time to market, which is needed in the modern automotive market. On top of it, going towards chiplet, it promotes innovation and differentiation due to the modularity. So the idea is to foster chiplet technology in the automotive sector. Chiplet technology has started early from the data center, let's say high compute intensive part of the electronic components and systems. And now it is somehow pervading towards automotive for the reasons highlighted before. To gain on manufacturing yield, because assembling several technologies together is more effective at function level in terms of manufacturing yield. You don't need to be at the leading edge for all your functions in the chip, which inevitably then will help in cost reduction and provide flexibility in the design and at the system level and faster development. So the customization and upgrades that is enabled by the chiplet approach is well aligned with the software-defined vehicle, and therefore it is an important topic. That is the reason of this call. And just citing one of the, let's say, many prediction is very important also because the high-performance system on chips altogether are growing fast and will increase their share in the total electronics, total automotive electronics. So just to highlight the issues, because they are challenges, obviously, coming from a monolithic SoC, disaggregating it means you need to communicate between the different chiplets and handle a number of, let's say, issues, including how to ensure functional safety, how to redesign the reliability, ensuring non-good dies issue, in particular, among others, related to quality and reliability, how to handle security, and all the, let's say, packaging aspects related to thermal management and mechanical stress. The perfect picture is here, different, let's say, from the overall ecosystem, different companies provide different IPs and different blocks for this chiplet. But this is the ideal picture, and to reach there, a number of aspects need to be addressed, particularly when it comes to interoperability of all of those blocks in the form of standardization, working on the interconnect technologies, the communication protocols, and so on. So the most essential part, and which is again the reason of this call, is to reach ecosystem collaboration. Among the hurdles on the way, ensuring the reliable integration with the necessary parameters of the different chiplets in modules, and the standardization across sector are essential topics. When it comes to the current ecosystem, and this is a slide coming out of the Pact for EU coordination and production, which finished mid of last year, there are two vertically integrated ecosystem for chiplet from Intel and TSMC. And it does not, let's say, it's not compatible with the need for a reasonably open and collaborative ecosystem as it is common with the automotive sector. And to reach this, which is standard for the system on chip, let's say, type of ecosystem, work is necessary on different dimensions, on the tools for, let's say, the system level modeling and the 3D integration. So that goes, of course, hand in hand, to make sure that this is accurate, and this is crucial to have the possibility to design the full system in module, in a sense, in one go, and to make sure that the complex automotive chiplet can be basically designed in a full ecosystem. So coming to the call itself, there are four main expected outcomes. So the automotive chiplet system framework is the very important starting point with the architectural and design specification, followed by the necessity to adapt the intellectual property blocks to arrive to automotive chiplet integration. The base die development, so basically the specific integration of those IPs into working chiplets is the next level. And finally, so it's kind of the full stack system integration and packaging to ensure that at the end of the day, the modules are automotive grade. As has been already mentioned by Waskar, by Georgi in particular, it is essential that there is clear link with the call on RISC-V hardware platform to make sure collaboration between the projects and consortia happen, so to avoid, let's say, double work and double work. So the focus is on automotive, but any other vertical is of interest. As I mentioned, it's important to ensure alignment with the automotive hardware platform, which is running in parallel, but it's two-stage. There is a call for a special emphasis on 2.5D integration as a first step, because it reduces a number of issues and potentially needs for faster developments. It should ensure tangible silicon demonstrators. And it's very important to inform back the community and the public side. So it is requested that a roadmap is developed with ambitious milestones to make sure the ecosystem benefits out of the results of the project. So very quickly here, I'm not going to detail, actually, we speak about one stage call. It will close on 29th of April. And as mentioned already by Georgi, we expect then a final selection in July, going for a project in grant agreement and signed actually by the end of the year. So 20 million budget, 35 maximum participants, strong participation of SMEs, and the same limitation. And I did not repeat the page numbers. They are the same for the full project proposal of the two other calls. And the funding rates are those of the research and innovation actions to incentivize actors to contribute broadly. Here we are for questions, so I give back the floor to Georgi, who will actually address this Q&A session.
Thank you. Thank you, Eric, for catching up also with timing. So thank you for your presentation. Thanks to all the presenters. May I ask our support team now to open, I see it's already open, the floors for questions. So I see one. Can you introduce yourselves? So it is Markus Bebendorf. Please.
Yeah, thank you, Max Biebendorf from Continental speaking. Yeah, I'm really happy to see that you're targeting with these programs exactly the main problems and the challenging topic in automotive industry for the future. I have some question, or especially to this horizontal or chiplet integration. I think it's a very, very important topic, as far as we see here a complete changing ecosystem, not only in Europe, it is worldwide, it is fast developing. And we see here activities also in other countries, Asia. Maybe you're aware of Asra Corporation, and they give us a good model how this could work. Only suggestion or idea, maybe also to talk about that. We need here much more to bring our forces together between OEM Tier 1 universities. And we should be careful from my opinion, what I see to split this budget in too many small pieces as far as it's a really large problem. A good example, what could be a nucleus also for this chip lab topic. I think we have activities also around the IMEC and the Baden-Württemberg Design Center, and that could fit perfectly to bring here everything together and maybe make one project to that and do not segment it in too much smaller ones.
Thank you for this. It's more a comment than a question, right? But I would only continue this comment that you as a community have the freedom to shape the right consortium with the right balance of participants so that indeed budget is not fragmented too much and at the same time you can deliver. So you have the critical mass which can deliver impactfully. By the way, this is one of the reasons there is also a limitation of the number of participants in all three topics, so that we would like to avoid too much fragmentation of the funding. And at the same time, I would like also to emphasize that we are at a stage where we really need deliverables which are close to market, which are mature, which are industry standard, which are also costly. So, but it is up to the community to shape the right consortia with the right representation, with the right parties there.
Thank you. So I'm only doubting a little bit in the investment. Maybe give you an example. Astra in such a commemoration spent around 240 million for the next 2 years or 3 years, and with the target to have a chiplet SoC available in 2030 for serious production. Yeah.
Okay, I see Max wants to get into this discussion.
No, I don't want to directly get into this because I don't want to really interfere with you on that. But what I would like to say from the perspective of the political perspective of the Automotive Action Plan, we know European automotive industry is under threat. So working together is important and not replicate what others are doing. So when we now look at this connected and autonomous vehicle alliance, where hardware, what you do here is part of this, we will also look how we can get the national programs, how we can get other fundings aligned. From my point of view, this doesn't work top down only. So we may have a general vision, but it has to happen within the companies and with member states. So that said means if your company, Markus, you're from Continental. If your company engages here and is also engaged in others, it's your role to ensure that there is complementarity in that. We often see this mentality, we apply for projects there and there and there, and then we see. I think it's important that you think about that from the outset, and then in your companies, make sure that this collaboration takes place. I can assure you, we are working at the moment on how we can better orchestrate that in this connected and autonomous vehicle alliance, which is, I would call the digital vehicle alliance, where you are part. Thank you.
Perfect comment, Max. Thank you for that. Maybe we have the chance to align. I think it's a little bit too much afterwards. Shortly, maybe to share some ideas here how to make this more efficient with a much better fitting result than we did in the past. Only an idea. Thank you.
Thank you. Thank you for the comments. Any other hands? Anyone to ask? Maybe I can just comment a bit further on some practicalities, because I was expecting actually to ask me how you can connect, how can actions or proposals take into account the actions that will be made by the other calls. So I would advise applicants for certain call also to go through the text of the other call that are interlinked somehow, and to take to put certain provisions in their proposals, taking into account what would be proposed in the other calls, so that there is not indeed overlap in the activities. And here in particular, I refer to the chiplet and heterogeneous integration with respect to the RISC-V hardware platform activity. So it would be useful to also have a look at the other, what is sought for in the other calls, call or focus topics. So that's kind of a practical tip for the for the applicants. Any other questions in the meantime? Okay, so then we can close 10 minutes earlier than this info session. Unless colleagues have anything to add, I would like to thank everyone for attending this session. I hope that after it, the global picture became more clear for you. I believe that we will have very good proposals submitted, and that we will be really selecting winning champions here. So thank you again. We're waiting, we're expecting your proposals, and I can only wish everyone good luck and success. Thanks, and we'll keep an eye on your submissions from now on. Thank you.
Thank you.
Have a good afternoon, everyone. Bye.
Bye.
Thank you.
Thank you. Bye-bye.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you. Bye.
Bye-bye.
Thank you. Bye.
Thank you.
Thank you.
Bye.
Bye.